Good morning, one and all. My name is Sudhakar. So I'm going to teaching about the basic manufacturing technology. In that we are discussing about the lathe machine, right? In the previous class, we learned about lathe operations, some of the lathe operations, right? They are standard operations, facing operation, turning, eccentric turning, step turning, taper turning, knurling, right? Let me recall them. Facing is the operation of producing flat surfaces. By doing it to do this operation, the cutting tool is moving per, right angle to the workpiece axis or perpendicular to the workpiece axis, right? So by doing this operation, we are producing flat surfaces. Next, turning. Turning is the basic manufacturing operation which is doing on the lathe machine. So turning it means it produces the cylindrical surface. To do this operation, we are giving some depth of cut to the workpiece by the cutting tool and feeding to the cutting tool, right, to parallel to the workpiece axis. The feeding is given parallel to the workpiece axis, right? By doing this, we are producing cylindrical surfaces. Turning is the operation of producing the cylindrical surfaces. In the simple way, we are telling that. Eccentric turning. In eccentric turning, we are doing two or more cylindrical surfaces at a time, right? In eccentric turning, by doing eccentric turning, we are doing two or more cylindrical surfaces at a time. Because eccentric means the two parts center not coincide. Next, step turning. So in step turning operation also, we are producing different diameters up to some different lengths, right? In different lengths, we are producing different diameters stepwise. So up to some length, some diameter, and up to some length, some diameter, and up to some length, some diameter, right? These are all about the step turning operation. Okay. And next, taper turning operation. By to produce the conical surfaces on the workpiece, this process is called taper turning. Okay. For producing the conical surfaces, we are doing taper turning operation. So conical surface, how we can produce? So to arrange our cutting tool some inclination to this workpiece axis, right? Arrange our cutting tool in some inclination to the workpiece axis. So we are producing this taper surfaces. So taper surface means the diameter gradually decreases and gradually increases from one end to another end. Right? The last operation is the yesterday's. In yesterday's session, we are learning about the last operation is that knurling. Knurling means we are producing some indents on the cylindrical surfaces by knurler tool. A special tool is called knurler tool. We are producing indents on the cylindrical surface by some special type of tool. That tool is called knurler tool. Why we are doing this operation? If we want to handle that object for gripping purpose, we are producing knurl on the cylindrical surfaces. By doing this knurling operation, indents are produced on the cylindrical part. So we can easily handle that object by gripping that knurling part. Okay, these are the operations we have learned yesterday, right? Facing, turning, eccentric turning, step turning, taper turning, knurling. These are all under the category of standard operations. which are done on the lathe machine. Okay. The remaining operations we will discuss today. So in this class, we are going to discuss about the drilling, reaming, boring, parting of, keyway cutting, thread cutting. So these are also main operations, standard operations which are performed on the lathe machine, right? So for doing drilling operation, we are having drilling machine, and the boring and reaming also we are doing on the drilling machine itself. If in our workshop we don't have the drilling machine for doing holes or something, boring holes, right? We don't have the drilling machine in our workshop, so we can do our drilling operation lathe machine itself. Okay, lathe machine itself, we are producing the drilling operations, right? So for that operations, we need drill bits. Whatever the hole we are going to produce, that sized drill bit we need. The drill bit is enough for doing the operations. And reaming also. For doing reaming also, we are having different types of ream bits, right? Boring. For boring also, we are doing manufacturing. Boring means enlarging the hole. But for this purpose, we need single point cutting tool is enough. The same way, parting of, keyway cutting, and thread cutting operations also done on the lathe machine, right? So drilling. First of all, we are going to discussing about the first operation, that is called drilling. Drilling, reaming, boring. These are all both are followed by one another. One by another operation. Drilling, reaming, boring, threading, parting of, keyway cutting. These are the standard or common operations. Yesterday we have learned. So some of the operations are taught yesterday, and today we are going to discussing about the drilling, reaming, boring, threading, parting of, keyway cutting. Okay. Drilling. It is the process of making hole on the workpiece. We know already in workshop technology we are doing this drilling operation. The drilling means what? We are producing holes on the workpiece, right? For doing this operation, we need drill bit. What are the size of the hole we need to produce on the workpiece? For that reason, we are having some size of drill bit. For doing that operation, we need that diameter drill bit. Okay. So how we are producing drill holes on the workpiece by doing on the lathe machine. The drill is fed slowly into the workpiece, which is revolving in a chuck. The drill is fed slowly into the workpiece, which is revolving in a chuck, right? So here is the drilling operation is different by comparing the drilling operations performed on the drilling machine, right? Can we recall that? In drilling operation, we are going to we are producing the holes on the workpieces, right? Okay. In that, workpiece is stationary and workpiece is holding in some device. Okay. So the drill bit, when we on the machine, the drill bit is rotating there. The drill bit is rotating there and entering into the workpiece by making some holes, by making holes on the workpiece. Okay. So what we have learned so far, the drill bit is rotating in drilling machine and the workpiece is stationary, right? Coming to this drilling operation, which is performed on the lathe machine, here the drill bit is not rotating here, just it is fed slowly into the workpiece, which is rotating here. Workpiece is rotating here. Workpiece is rotating. Okay, so the workpiece is rotating in a chuck, and the drill bit is fixed in the tail stock, where our drill bit is fixed in lathe tail stock. So that is the stationary drill bit in lathe tail stock, and the workpiece is rotating in a chuck. The drill is held stationary in the tail stock spindle, right? Observe here, the picture shows that drilling operation. So this is our tail stock, and it is a workpiece which is fixed in a 3-jar chuck. And the workpiece is rotating. Workpiece is rotating, and here the drill bit is there. So the drill bit is fed into the workpiece. The drill bit is fed into this revolving workpiece. Okay. By doing this, small amount of material is removed from this material, and the required hole is produced. Required size of hole is produced by doing this operation. Here we have to remember what is the main point in general drilling operation. The workpiece is stationary and the cutting tool, the drill bit, is rotating and fed into the workpiece. In drilling machine, in drilling operation which is performed on lathe machine, the workpiece is rotating, not the drill bit. The workpiece is rotated and the drill bit is stationary, that is fed into the workpiece. Okay. By doing this operation, we are making the holes on the workpieces. So observe here, drilling operation is happening. So it is rotating, the workpiece is, and the cutting tool is fed into the workpiece. The material is removed in the small amount of chips. Material is removed by the amount of chips. So after doing this operation, the component is looking like this. Okay. This is the hole we are produced here on the workpiece. So this is the drilling operation which is performed on our drilling machine. Next, reaming. Reaming is also making holes, but it is the finishing process, right? We are by drill bit we are producing rough surfaces in the hole. So for finishing, for smoothing the hole, okay, so we need a reaming operation. That means reaming is the process of making hole smoothly and accurately to the size. Reaming is the process of making hole smoothly and accurately to the required size. Suppose we need to produce 8 mm hole. By doing drilling operation, we are producing 7.88 mm or something. Rough machining operation, rough drilling operation is happened by the drill machine. So we have to finish. After checking that hole size, we are not getting our requirement. So again we are going to the finishing operation, that is reaming operation. By reaming operation, we are removing only small amount of material. Why this process is helpful for us? This process is helpful for us only for giving smooth surfaces and accurate size. Okay. So here also same, the workpiece is fixed in a check and it is rotated, and the reaming bit is inserted in a tailstock. Reamer is inserted in a tailstock, and the workpiece is rotated. The which part is we have to already drilled hole is held in a check. Workpiece with drilled hole is fixed in a chuck, that is rotated, and the reamer is fixed in a tailstock spindle. So that reamer is fed into the workpiece. The reamer is fed into the workpiece. It is the line diagram of reaming operation. Here This is the workpiece. This entire part is the workpiece, and it is set. This is the hole. Already we are produced part. This is a hole. Here it is a tail shaft and it is a chuck. In this we are fixing our reamer. So it is rotating. So just we are giving feeding to this reamer. It is entered into this hole and removing small amount of chips, like grinding operation. In grinding operation, it is a finishing operation, not a not a manufacturing operation. It is a finishing operation. Finishing operation means for giving smooth surfaces or excess material. After doing some operation, we are having some excess material on the part, or not finished or not finished parts. We are doing that finishing operations. Right here also, after doing drilling operation, we produce the hole to to finish that size of the hole, or accurate size to that finished part, accurate size to that drilled part, we are going to do this reaming operation. Okay, so it's the reamer that is entering into the already drilled hole. So these are the reamers, different size reamers. Based on our requirement, we are using different size of reamers. These are fixed into this tail shaft by doing that, or do that operation. Okay. Reaming is the process of making hole smoothly and accurately to the size. It is not actually making the hole in drilling operation. Just it is only for using the smooth finishing operation, right? Next, the last one is the in this drilling operation, boring. Boring is the operation of enlarging the previously drilled hole with the aid of single point cutting tool called boring tool. After doing drilling operation, we are not getting our required size of the hole. Again, we are not doing the operation with the drill bit for getting that required size. We are going to another operation, that is boring operation. Boring operation means it is the enlarging the previously drilled hole with a single point cutting tool called boring tool. If the hole is enlarged only through a certain length, it is referred as counter bore. If the hole is enlarged only through a certain length, then it is referred as a counter boring operation. If the tool is fed at an angle to the axis of rotation, it is called internal taper cutting. Right? Here we have to observe these 2 points. If the hole is enlarged only through a certain length, then it is referred as a counter boring. Right? We are doing drilling operation. We are producing the hole up to some size. Suppose 8 mm length, we are doing drilling operation and producing the hole. The hole size length is 8 mm and the diameter of that hole is 12 mm. Here is the not matter of diameter of the hole. Here the matter is length of the hole is 8 mm. So what we call here counter boring means uh, boring is the operation of enlarging hole. So we are doing now enlarging a hole. The length of the hole is 8 mm, but we are doing boring operation is up to 4 mm. The remaining 4 mm is having the diameter 12 mm, and the remaining the main part of the boring operation, the part of the hole size is 13 mm. Let us take some example. The boring part hole size is 13 mm and the remaining part which we are not doing the boring operation is 12 mm. The part which is enlarged and the part which is not enlarged. That total part is called counter boring operation, right? If the hole is enlarged, not entire the length, only some part of the length, that part is called counter boring operation, right? The hole is not enlarged. The hole is not enlarged by the total length, right? It is only, it is, the hole is not enlarged for entire length. It is only enlarged up to certain length. That is referred as a counter boring. If the tool is fed an angle to the axis of rotation, it is called internal taper cut. Okay. So here is the counter boring is the straight process. Same counter boring operation is done by with some inclination and doing some taper shape in that hole. That part is called internal taper turning operation. So here the boring principle. So this is the workpiece, the part, continuous speed of motion. Here we are having this. This is our cutting, single point cutting. So it is doing this operation. So this is our workpiece. Here we are having single point cutting tool. It is doing enlarging the hole. After completing boring operation, now we are moving to the parting off. Parting off is the operation of separating the finished workpiece from a bar stock. It is a cutting operation. Completely we are discarded the part from one another, right? It is the operation of separating the finished workpiece from a bar stock. The operation involves feeding the cutting tool into the rotating workpiece. The operation involves feeding the cutting tool into the rotating workpiece. By doing this operation, parts are separated from one another. Okay, the name itself tells that part off, parting off. It is the operation of the finished workpiece from a bar stock. Okay, in this operation, the feeding, we are giving the feeding to the cutting tool into the rotating workpiece. So here we are observing the parting of the diagram. So this is the workpiece, bar is a bar. Okay, here our cutting tool is there, which is used to cut the parts. Okay. We are giving continuous speed motion in this direction. Okay, it is a z-axis and it is x-axis. Okay, feeding is in x direction, workpiece axis is in z direction. So continuous speed motion we are giving. So workpiece is not moving this way and it is not doing on this surface. Entirely it is working on the portion of the part. So by giving feeding, continuous feeding to this workpiece, here amount of material is removed in the form of chips. After doing so much, after doing time, so the entire part is removed by in the form of chips. So after removing this form of chips, this part and this part are separated. These two parts are one separated. So this operation is called parting of operation. Parting of operation means separating a finished workpiece from a bar stock. Separating. We are a lengthy bar stock fixed. We are a bar stock fixed on the chuck. We need cylindrical part up to some length, or we need a stepped part, or we need conical part, or we need some finished part up to some length. So we need that part. For that reason, we have to cut that part from the total length of the part, right? So for this reason, we are doing the parting of operation. The parting of operation is the separation of finished part from the bar stock. In this operation, it involves feeding the cutting tool into the rotating workpiece. Feeding the cutting tool into the rotating workpiece. Okay. So we are giving feeding in X direction, it is rotated in Z direction. So both parts will be separated by one another. So after completing all operations, we will see some video on all operations. Okay. The next operation is the keyway cutting. Keyways, nothing but grooves. Okay. So where the assembled parts are there, where we have to couple two parts, we need the keyway, right? In that keyway, we are fixing some keys, right? If we want, we are going to attach two parts, right? Two rotating parts. We need a keyway on one part. In that keyway, we are provide keys on that keyway for tightening of the two products. Okay. For cutting keyways on the lathe, work is held in special attachment on cross line. For doing this operation, we need a special attachment. That attachment is on the cross line. We are doing these keyway operations in milling machine. That will be in our further study. It will be further studies will come the subjects. We will do keyways on lathe machine also. To do cutting the keyways on the workpiece, we need a special attachment. That attachment is on the cross line. Okay? For cutting keyways on lathe, work is held in special attachment on cross line. The cutter is held in a chuck and made to rotate. The cutter is held in a chuck and made to rotate. The work is fed against rotating cutter to form a keyway or groove. Here observe these points. The cutter is held in a chuck and it is rotating. The keyway cutter is rotating on the chuck and it is fixed in the chuck. The work which is we need groove on that workpiece is fed against rotating cutter to form a keyway or groove. Okay. The work is fed against a rotating cutter to form a keyway or groove. So this keyway cutting operation we will observe in the video. Okay, video. How the lathe machine operations have been done on the lathe machine. That will be coming in this PPT only, this video lecture only. After this all operations, you will see that keyway cutting operation which is done on the lathe machine. Okay. Next, threading. Already we know about the threading operation, how the threading operation is done. To do the thread cuts, we have to engage some mechanism, that is split nut mechanism or half nut mechanism. What are the mechanisms? Split nut mechanism or half nut mechanism. So threading means cutting grooves, but the shape of the grooves are maybe they are helical grooves. Okay, the helical grooves over a cylindrical surface or conical workpiece is called thread cutting. Right? Keyway cutting. Cutting means threading means we are doing grooves that are helical grooves over a cylindrical or conical workpiece is called thread cutting operation. Okay. So this is the thread cutting operation. So we are giving feeding to our thread cutting tool. We are giving feeding one by one to this workpiece on the workpiece. So threading means producing helical grooves on the workpiece on the cylindrical surface. Using helical grooves on the cylindrical surface. So in this picture we are observing clearly the thread cutting operation is. So these are the threads which are formed on the cylindrical surface. To do this thread cutting operation, we need to engage the lathe machine to split nut mechanism or half nut mechanism. Split nut or half nut mechanism we have to engage, then only we can do the threading operation. So these are all the operations which are performed on the lathe machine. Right? Can we recall them one by one again? Right? So the standard operations are carried out on these: drilling, reaming, boring, parting off, keyway cutting, thread cutting. Drilling operation. Drilling means producing the holes on the workpiece. Earlier, we are producing holes on the workpiece by drilling machine. We are not having the drilling machine in our workshop. We are only having the lathe machine in our workshop. The drill bits are enough to make the holes on the workpiece. The drill bits are enough to make the holes on the workpiece. And next, reaming. After doing drilling operation, some of the excess material within the hole or rough surfaces are produced after doing the drilling operation. Rough surfaces are produced by doing the drilling operation. So for that reason, we are doing the reaming operation. The reaming operation is doing the sizing the hole and finishing the hole. Sizing the hole and finishing the hole. After doing this reaming operation, the hole is having good surface finish and it is getting accurate size. Okay, the hole which of the size we need, that size is up here. Next, so for doing these operations, the drilling operation, we need drill bits, and reaming operation for we need reamer. So we can also call this drilling and reamers or multi-point cutting tools because they are having multi-cutting edges. Okay, multi-cutting edges. That's why they are called multi-point cutting tool. Why we are called it as multi-point cutting tool means. Next, we are going to discuss about the boring. Boring operation. Boring operation means it is used to enlarge the hole. To doing this operation, we need a boring tool that is a single point cutting tool. Why we are called it as a single point cutting tool? Because it is having a single point cutting edge. That's why it is called as a single point cutting tool. In boring operations, two sub operations are there: counter boring, internal taper turning. Counter boring, we are producing the hole to some part. So that is called counter boring operation. Counter taper, internal taper turning. Internal taper turning, we are making taper shape in the hole. So that operation is called internal taper turning. Parting off. Next we are moving to the parting off. Parting off means we are removing the finished product from the bar stock. We are removing or we are cutting the finished product from the bar stock. That operation is called parting off. Okay. So for parting off, the cutting tool is fed directly into the workpiece. Next, keyway cutting. Keyway cutting, we are producing keyways on the workpiece. For doing this operation, the cutter is in check and the workpiece is fed against that cutter. Okay, so in that keyways, we are giving the keys, we are putting the keys. So these keyways are used when we are assembling two products or when we are doing coupling with two products. For that rotating parts, we need keyways. The next operation is thread cutting. Thread cutting operations means we are using helical grooves on cylindrical surface or conical surface. It's called thread cutting operation. Thread cutting operation is producing helical grooves and what? Helical grooves on cylindrical surface or conical surface. That parts are called thread cutting operation. So these are the operations we have learned today: drilling, reaming, boring, parting off, keyway cutting, thread cutting. In yesterday's class we have learned that facing, turning, taper turning, eccentric turning, step turning, right? So let us do some quiz questions. Machining operation in which tool rotates and work stationary is. Tool rotates and work stationary. What is that operation? A drilling operation. In that, tool is rotated and workpiece is stationary. That's why it is called as a drilling operation. Reaming is a process we know already. It is a finishing process. Making a hole, or making a hole means it is a drilling operation. Of making a smooth hole, okay. Enlarging end of a hole. Enlarging means it is a boring operation. And not is the last option. So what is the correct answer? Of making a smooth hole. The correct answer. Okay. So after this PPT, we are going to see some video on the lathe operations. Then only we can understand easily. Okay. Now we are moving. So in this video, we are observing different types of lathe operations. First of all, we are going to see the facing operation. Facing is the operation of producing flat surfaces and also it reduces the length of the workpiece. Next, turning operation. Turning operation is means it produces the cylindrical surfaces. That means it reduces the diameter of the workpiece. Turning is the machining operation in which excess material is removed by rotating the workpiece against the cutting tool. Observe that how we are giving the feed. We are giving longitudinal feeding, that is parallel to the axis of the workpiece, and again the depth of cut. Now, it is the knurling operation. It is the process of indentation of various forms on cylindrical surfaces. Do cutting operation. Grooving is also known as recessing, undercutting, or necking. The workpiece is fixed between the two centers, or workpiece is held in a chuck. We are having the groove tool. The grooving may be in the form of square or round or in angular. These are the grooved parts. The function of groove is usually to allow room for a fitting part. Grooves also provide a leaf in the back side of a thread where the thread terminates. When it terminates, drilling. So we are fixing or drilling the drill bit in headstock. This is the holes on the workpiece. Reaming is the operational position sizing for which has been previously filled off board. The reamer is filled on the tailstock spinner either direct or through a drill chuck and filled essentially when the workpiece is revolved at a very slow speed. The finishing operation or a sizing of the hole. Reaming operation is the finishing or sizing of the hole. boring operation. Boring is the enlarging operation. Enlarging of one operation is having the single point cutting tool. It is called a boring tool. What is boring tool? Material is removed for chips. So I have told that counter boring, we are doing enlarging the hole up to here, but the hole size is to here. But we are doing hole up to here only. We are doing hole up to here. So that's why it is called as a counter boring. Parting out, separating the part from one another. So these are the operations are performed on our lathe machine. Okay, I'm closing this session today. We will discuss in the next class.